Good afternoon, students. All of you know your council will take two semesters, first semester and second semester. Okay, so we have already discussed now that only semester, first semester will take the exam for half yearly exam. Okay, so whatever we have completed, suppose integration, that is definite. I have already started definite integral. Okay, so we will not do now. We will not do. Okay, now your syllabus is there, first semester, and that is significance of derivative is there. Okay, the tangent normal and maximum minimum also there. That significance of derivatives. This chapter is there. Okay, put some in. I'll discuss now significance of derivative. So right, significance of derivatives. I'll discuss. Okay. So all of them, the first principle formula dy dx or f dot x, we know limit h tends to 0, f of x plus h minus f of x by h. So all of you know this formula. That is first principle of dy dx. Okay, this is the first principle of dy dx. Acha. Now see, suppose x axis, y axis there. Okay. Now one curve is there, I see. The curve is there. Suppose the point P is there, xy and q. Suppose x plus delta x, y plus delta y. The coordinate of q, x plus delta x and y plus delta y. So delta x, all of you know, is very small. That is increment of the value of x. Okay. Now draw here perpendicular. Here also perpendicular. So this is suppose PQ R suppose constant. If this is theta, so this angle also theta, no, and this value will be delta x, and q taking, so this one will be delta y. So you can write here tan theta equal to delta y by delta x. You can write, see, tan theta delta y delta x. Okay. Now if delta x tends to 0, that means if the point Q moves towards the point P like that, see here the point x plus delta x like that. When you come from the point here, okay, the point Q moves towards the point P, that when delta x tends to 0, then this line, this line will be diagnosed, you know, here like that. This the tangent is there. Suppose this angle is suppose phi. This angle is phi. If the point Q moves, that is, if delta x tends to 0, Q tends to P, then delta x tends to 0, then the line will be tangent line is there. No, see, this is the tangent line is there. Tangent. So when limit theta tends to psi, tan psi, sorry, right, tan theta, then limit delta x tends to 0, delta y, delta x. Okay. So tan psi, you can write this value, all of you know, this will be dy dx or f dot x. Okay, that is tan psi means gradient of the point, gradient at the point xy, suppose dy dx. So what is the geometrical significance? So the function y equal to fx is given. So this function is there. Suppose y equal to f of x function. Whatever the function is there in this one, y equal to f of function. Okay. The function y equal to fx, the derivative of the function represents the tangent, okay, of the line AB. That is dy dx equal to represents the gradient of the line, tangent line. Okay, y equal to f of x. Okay, that is denote f dot x equal to dy dx. Okay, so all of you remember this one. And delta x, very small chart discussion in class. This is not your syllabus. Change of delta x, delta y is not your syllabus, but it's in there in entrance exam also there. I'll discuss. Okay, this part. Now, students, look at here. So y equal to f of x function. So dy dx f dot x represents tan theta. That is tan psi or tan theta, you apply, no problem. Okay, represents derivative of a function, represents at that point will be tan theta. That is tangent of the line. Okay. So right here, dy dx f dot x, dy dx is there. Suppose dy dx greater than 0. The value f dot x greater than 0. So we can write here tan theta. Suppose constant tan theta equal to 1. Greater than 0. No? So it will be tan 45 degree. So theta will be 45 degree. So if dy dx greater than 0, keep in mind, then it represents, that is, acute angle is formed. The angle in 45 degrees there. Okay, so this in the positive direction with the x-axis, it makes angle theta, that is 45 degree with x-axis. That is acute angle is formed. If dy dx less than 0, then obtuse angle is formed. Obtuse angle. This is acute angle. Okay. And if dy dx equal to 0, then the line parallel to x-axis. Parallel to x-axis. If dy dx 0, the line parallel to x-axis. Okay, that means dy dx at the point, suppose x1, y1 represents slope of the line of the function. This is the slope, gradient of the point. Okay, and minus dx dy, we have to write x1 y1, that is normal slope of the tangent. Okay, this is the tangent line, and this is slope of normal. So right, slope of normal. Okay, this is gradient of tangent, and this is represent, this is normal. Then what is the equation of tangent and what is the equation of normal? Look at here, I am showing. Suppose x axis y axis. So tangent is there. So this is tangent line. The curve is there, like the curve. At the point, suppose x1 y1. It will be any point x1 y1. So this makes angle theta with positive direction of x axis. And here, if you draw perpendicular, so this is n. So this is perpendicular. So Pn, the point P is point of contact, and this foot of the perpendicular Pn, here P, that Pn is known as normal. Okay, and this is normal. The gradient of normal will be minus dx dy. Okay, now write equation of tangent y minus y1, m means dy dx at the point, that point x1 y1, x minus x1. Okay, and equation of normal, right, y minus y1 minus dx dy. Okay, or 1 by minus 1 by dy dx, remember, x minus x1, x1. Okay, so if you remember dy dx is equal to 0, then if dy dx is equal to 0, then we can say y equal to y1, then the line parallel to x axis. Okay, and dx by equal to 0, this will be perpendicular on x axis there. Okay, this is perpendicular, y equal to y1. Okay, now in all over velocity, suppose distance s is given, s or x, the distance, suppose in the time of 80 square plus 280, 2bt plus c is given. So dx dt in this time t, 280 plus 2b, and d2x dt2, so twice in, so it represents d2 dx dt. This is v, velocity. Okay, and this is dv dt, means acceleration is there. So a or f, all of you know this one acceleration, d2x, or you can write dv dt, you can write dv dx of dx dt, dx means v, no? So v dv dx. Always remember. This is acceleration. A is there. dv dt. Okay. V dv dx or d2 is dt2. Keep in mind. Okay. This is there also. So the sum. Now suppose fx, right, x plus 1 by x is given. So f dot x find out 1 minus 1 by x square. Okay, 1 by 1 minus x. Then f dot x suppose 0. Then we get the point, see, 1 minus 1 by x square will be 0, no? So x will be plus minus 1. So if x 1, y also 1. X equal to suppose minus 1, then y also minus 1. So this is the first point is there. Suppose first point here, find the equation of tangent. So write equation of tangent y minus y1 dy dx at the point x1 y1 x minus x1 y. So write y minus 1 dy dx is there now at the point. If you put 1, so 1 minus 0 is there. X minus x1 is 1. So y minus 1 equal to 0. That is y equal to 1. Here, the tangent parallel to x-axis means dy dx equal to 0. Tangent parallel to y-axis is given. Sorry, parallel to x-axis. Then dy dx equal to 0. So we are getting y equal to 1. Y minus 1 equal to 0. Okay. So this is the first quadrant point is there. Tangent equation will be y equal to 1. Okay. Now another question will suppose x is cube y cube, so right, x is cube plus y cube equal to thrice axy. This is given. Find the slope at the point, that is minus 3 by 2 minus 3 by 2. Find the gradient. So first find out all of the dy dx. Just put dy dx. So 3x square 3y square dy dx 3a on y plus x into dy dx. So 3 cancel on both the sides, so write y square minus ax of dy dx ay minus x. So dy dx ay minus x square by y square minus ax. Okay. Now dy dx at the point, so x equal to minus 3 by 2, y equal to minus 3. Just put the value. A into minus 3 by 2 minus 9 square by 2 divided by y square 9 square by 2 minus ax means minus 3 by 2. Okay. Now look at here. So if you minus here, one plus is there. So both same. So minus 1 is coming. So gradient dy dx at the point this minus 1. Then it represents its obtuse angle is formed with positive direction of x axis. So dy is negative means it represents obtuse angle. It makes obtuse angle with the positive direction of x axis. Okay? Understood? See. Okay. Now see, suppose V is the volume of a sphere. S surface area. Okay, surface area of a sphere. They find the relation between dv dt and ds dt. Find the relation between dv dt and ds dt. So write sphere radius if r, then volume all of you know 4 by 3 pi r cube. So write v 4 by 3 pi r cube can write. So write dv dt you can write here 4 by 3 pi, that is 3 r square into dr dt. We cancel it, 4 pi r square of dr dt dv dt. Okay. Now s is there, you know 4 pi r square surface area of the sphere. So ds dt right 8 pi r of dr. So here dr dt you can write ds dt by 8 pi r. Just you put here 4 pi r square. So ds dt by 8 pi r. No? Now pi cancel it out. So r by 2 ds dt. Yeah, dv dt. So you can write here 2 into dv dt r into ds dt. All remember. 2 into dv dt equal to r into ds dt. Okay? So remember this formula. Okay, no more today. Again next I will discuss. Okay? Okay, bye.